Let's talk a bit about serialization today. More specifically, I want to talk about JSON serialization. So we're not going to do any of the other fancy formats. We're not going to address protobuf or anything like that. And we're going to talk about JSON serialization specifically on the JVM. So we're also not going to address anything multi-platform for now. The way that I started preparing for this talk initially is, well, almost 2 years ago now. I asked this question on Twitter, just trying to poll everyone to see what kind of libraries they were using in Kotlin and on the JVM to do serialization. And since we're in an actual physical room, I can also poll the room now. So for example, who's using Gson to do serialization here? Anyone using Gson? Okay, couple people. Anyone using Moshi already? Which is in the title of the talk. Okay, that's a bunch of people. Anyone doing Kotlin X serialization? A similar amount of people. And then anyone using Gson? A lot of people. Excellent. Okay, you're the correct crowd for this. So 2 years ago, these were the answers. As you can see, Gson was by far the most popular. This is like not a representative data set. It's random people on Twitter, but still, a lot of people answered Gson. Moshi was trailing a bit behind, and Gson and Kotlin X were really not popular back then. Then I ran this a week ago, so a lot later, and now as you can see, the results were a lot more mixed. Gson, Moshi, and Kotlin X serialization all roughly had the same amount of votes, and Gson was again trailing quite far behind. But not to just show my own data from Twitter, here are some things that JetBrains has gathered. So on the left-hand side here, you can see stats from the Kotlin Census 2020, and on the right-hand side, it's the JetBrains State of the Developer Ecosystem Survey from this year. And this question was what third-party libraries people are using in Kotlin. So Gson was the top result for both of these. There were other things such as Gson, which was really high up. Apparently, server-side developers really like using Gson with Kotlin. And Kotlin X serialization is not a third-party library, but I hacked it in there into the results. And as you can see, that's also gaining popularity. It has like 20, 30% adoption amongst Kotlin developers. So the takeaway is, oh, and by the way, Moshi is not on this slide. So it's just not present in any of JetBrains' surveys for some reason. So the takeaway is that Gson is still super popular, both in this room and in these surveys. So let's talk about Gson first. So Gson is Google's JSON serialization library. And let's just look at some basic usage of Gson first. So you can do something like this with Gson. You can create an instance of it. You can call from JSON. And you can pass in a string, as well as a type that you want to construct from that JSON string. And Gson will parse it into your model object for you. And you can do this the other way around. You can call Gson to JSON, pass in a model, and it will serialize it into a string. And I've actually seen this pattern of just constructing Gson instances all over the code base in multiple code bases. So let's just note that constructing new instances of things is never free. Obviously, it comes with an object allocation, but the Gson constructor also does a bunch of things. It's calling getters, it's setting fields. You should not be doing this all over your code. Instead, you should be constructing a single instance of this and then injecting that everywhere and reusing it. Not that you should be using Gson, but we'll get to that in a moment. So let's take a look at how Gson deals with built-in types. And I need to hack around something because I forgot to prepare. OK, awesome. I should be good now. So let's take a look at how Gson deals with built-in types. So for example, you can take a date instance and run it through Gson without configuring anything on it. And Gson has a built-in behavior to serialize dates. So if you run run a date instance through Gson, it's going to give you this human-readable string as the output. And so it's not really something that you would expect to pass over the network in a serialized form. It has like October in it. It doesn't have any time zone information, which is terrible. So it's just not a great approach. Gson will also serialize a calendar for you if you try that. And it also comes with a default implementation for this. And it does not do anything similar to what it does for dates. Instead, it constructs an object that has different fields in it, which is like a nicer way of serializing time information, but still not amazing. And Gson will also serialize things that it does not have included adapters for, such as just a random instance, for example. And it will output just whatever fields the object contains. It will just use brute force Java reflection, go through all the fields and nested objects inside this random object, and it will serialize all of that into JSON. And well, you can see really exciting things here. We have this nested object for seed. By the way, this is dependent on the JDK version. So if you run it on a newer version of the JDK, seed is no longer a nested object. It's just a long value. So you would get different outputs depending on the JDK version, which is also great. And yeah, you just have a lot of fields here that don't really make any sense to serialize like that. Let's take a look at field naming with Gson next. So you can create instances of Gson with just the constructor call, but you also have a Gson builder that allows you to customize a couple of things, like set global configuration options on Gson. And you can use this, for example, to set a field naming policy. For example, you can use lowercase with underscores. And if you then create model objects that follow the Kotlin coding conventions and have these snake-cased property names like total cost and sales price here, then you can serialize that object, and you're going to get lowercase with underscores style in your outputs. So in total cost and sales price, we now have those underscores. This is not great. For example, if you have JSON that you're looking at in your server logs or something, and you want to look up where those JSON fields are being used in your code base, it's harder to search for them now because you have to keep in mind that there's this implicit conversion between the two kinds of casings of the names of the properties. So total underscore cost will just not give you any results in your Android code base. You have to remember that you have to convert that into camel case and search for that instead. Instead of this global field naming policy, something you must have seen used a lot with Gson is this. You can set the name of each individual property instead, which makes it at least a bit more searchable. Now there's going to be a single result in the code base if you look for these JSON keys. And you can go on from there to find the usages of the properties. Let's take a look at what Gson does when some things go wrong, when some data is missing when we're trying to parse it. So we're going to start with this burger class, which has a name and a price. And we're going to try parsing that from a JSON string that only has a name in it, so the price is missing. Gson is going to accept this just fine. It's going to use a default 0 value for the primitive int that we have in our class, which should really bother you. So you're not going to get any errors during parsing, but you're going to have this 0 value that you might then take and do something with in your application. If you take the average price of your burgers, your calculations are going to be off. And this is going to be something that's quite hard to notice because you have no idea that this default 0 behavior ever kicked in. And also, you might just be selling burgers for free if that happens. On the other hand, if you have a reference type that's missing, so if we were to have a description in our model object, which is not present in the JSON, Gson is also going to be able to parse that, and it's going to leave a null value there for your description, which again is really troubling as a Kotlin user because now you have a non-nullable string, which is actually null when you access it. So whenever you do something with that string, you're going to get a null pointer exception at a random point in your code. This still might be better than the 0 value, which can corrupt your application logic and travel all throughout your app without ever crashing, but it's also quite problematic. And of course, we can try using Kotlin features such as default arguments for properties, and Gson is going to go ahead and ignore all of that for us and just still parse null values. For the ultimate example of incorrect data, we're going to take these models. We're going to still have our burger, but we're also going to have a restaurant now which has a list of burgers on its menu. I'm going to use this JSON that I'm going to try to parse. It has a list of burgers with the caveat that I've priced the last burger to be a crocodile. And if I try parsing that with Gson, it thankfully does not coerce crocodile into an integer. It actually crashes for once. It gives you this number format exception for input string crocodile, which if this string is unique enough in your JSON, then you can actually look up what happened. So I could go to my JSON in my logs, I could search for a crocodile, and I could figure out that that's the point in the JSON that was incorrect. That's what I was trying to parse into a number. But imagine that it was an empty string that this conversion failed on. Now you have to go through your JSON and look at each empty string and try to figure out if you tried mapping any of those to any kind of number at any point. So it's really hard to debug this. So with some of those problems in Gson highlighted, Let's now go ahead and do something better and say hi to Moshi. I also didn't introduce myself. My name is Márton. I work as an Android developer advocate for Stream. Check out our chat SDK. We're on all of your lanyards. And I'm not affiliated with Moshi or Square in any way. I just really like this library, so that's why I'm talking about it. So I already spoiled it that Moshi is a Square library for serialization. And it's actually part of a group of libraries by Square, which you hopefully know, which are these OK libraries. So OKIO, OKHTTP, Retrofit, and Moshi. And all of these libraries work stunningly well together, not just in terms of convenience, but also for performance reasons. I'm going to have an hour-long talk by Jake at the end of this talk in the resources, which tells you all about how these libraries can share buffers under the hood really efficiently and how they avoid copying data more than they need to and so on. It's really quite amazing, and that talk alone will probably convince you to try using these together. In this talk, though, we're just going to keep focusing on Moshi, and just like we've done with Gson, we're going to look at how you can use it, starting from the basics. So first of all, you would include Moshi as a dependency. This is very basic things. You add this to your Gradle scripts. Then we need something to serialize, and I'm actually going to start with a Java-based class. Bear with me here. We're going to move back to Kotlin in a bit. But I'm going to use a Java-based implementation of this burger, which has a name and a price, and all of the boilerplate of constructors, getters, and setters that Java requires. To create an instance of Moshi, we cannot call Moshi's constructor. Instead, we always have to go through the builder, even if we just create the builder and immediately build it. This will hopefully at least discourage people from creating new Moshi instances all over the code like they used to do with Gson. And after that, you might expect Moshi to work in a similar way as Gson did, so to be able to call to JSON on the Moshi instance that you have, but that's actually not something that exists in this case. Instead, you have to use this concept of adapters. So whenever you need to do serialization work with Moshi, you first need to grab an adapter from it, which you can do with the adapter method, passing in the type that you want to use. And that's going to give you a JSON adapter, which is a Moshi type. And on that adapter, you'll find the methods that you're looking for, such as toJSON, which will serialize something into JSON, as well as fromJSON, which can parse it back. And this works fine by default, just with the setup I've shown you for Java-based classes. It uses Java reflection tools to do this work. But if we try to convert this burger into a Kotlin class, then not when we're, so we don't even get to try calling toJSON or fromJSON at this point. The moment we try to fetch an adapter for this class, Moshi is going to fail with this huge exception. Which looks a bit scary, but it's actually super useful because it's a very descriptive error message. So first of all, Moshi recognized that this class is defined in Kotlin, and it tells us that it can't serialize it. Why? Because reflective serialization is not supported for Kotlin classes with Moshi without using Kotlin reflect. So Moshi recognizes that if it was to try using Java-based reflection to deal with this class, it would fail in similar ways as Gson, as we've just seen Gson struggle. So Moshi actually wants Kotlin reflect to be included in the project and use Kotlin-based reflection to properly interpret Kotlin language features. And it actually tells us how to do that. It tells us that we have a separate artifact we can include and an adapter to use. So we would go back to our build files. We would add the Moshi Kotlin dependency. And we have to configure the builder now to add this Kotlin JSON adapter factory. So this now uses Kotlin's own reflection capabilities. And now we can actually fetch the adapter, serialize, and then parse the JSON back. This approach of using reflection with Moshi works fine. This is something that you can choose to do. However, there are people who tend to be concerned with the runtime cost of reflection, so you might want to avoid this. And also, I checked it yesterday, and I believe that Kotlin Reflect is like a 3 megabyte dependency, which might be something that you want to avoid in your applications. So it would be nice to have an alternative to using this really heavy reflection-based approach. And we can just go back to the exception message, because it actually continues to say that you can also use code generation using the Moshi Kotlin CodeGen artifact. The way that you would do that is by adding it as a capped dependency, for which you need to make sure that you have the capped plugin for Kotlin-based annotation processing enabled. And this plugin, and this dependency will now generate Moshi adapters for your classes at compilation time instead of using runtime reflection. So let's see what that looks like in code. Let's say that we have this burger class still. We have to annotate this because annotation processors can only work with things that are annotated. We have to annotate it with JSON class and specify generate adapter true as a parameter, which will generate an adapter for this class. After that, the usage of Moshi remains the same as previously. So just creating the blank builder will actually pick up all of the generated adapters automatically, and we'll be able to grab that adapter and use it for our serialization needs. You can also use both of these setups of Moshi that I've shown you at the same time if you want to. For example, if you're migrating from one to the other, this might be useful. So in this case, for the classes that you have annotated, you're going to get the generated adapters. And for everything else, Moshi is going to fall back on the reflection-based approach and use that instead. Now, not only can you use reflection or generated adapters, you can, of course, also create your own custom adapters for whatever your serialization needs are. And you can either do this by implementing the JSON adapter interface we've seen before, or you can just create a class that has a from JSON and to JSON method with the appropriate signatures. We're going to take a look at implementing one of these, just because the two directions look pretty much the same. So here, we're going to implement this from JSON method that takes a JSON reader, which is a Moshi-defined type that allows for streaming deserialization. So we're pretty much reading directly from the socket using OKIO here. This is really efficient. You can do parsing while the rest of the response is still coming through the network and all of that. And we need to parse a burger out of this reader. So one way we could do that is we could create local variables to store the name and the price of the burger. Then we can access methods on the reader such as begin object and end object, which would consume the curly braces that bound the JSON that we have in the reader. Then we could loop through each of the JSON keys and values that are present in the JSON object, and we could check what the name of each value is. So if we find name as the key, then we would read the next string and put it into the name local variable. And if we find price as the key, we would read an int from the reader and put it into the price local variable. And everything else we can just skip safely. And of course, at the end of the method, we want to create a burger. So we would construct a burger here and hope that we actually found both of those values while we were parsing. So this is a very simple implementation of a custom Moshi adapter. Well, half of it anyway. Now let's take a look at what Moshi generates for you if you're using the CodeGen-based approach, because there's quite a few interesting things in there. So this is more code than what we've just written, but it's for a very good reason. So starting off here, first of all, let's note that Moshi generates Kotlin code, which we should be quite happy about. So on the one hand, we don't bring more Java code to the world. And on the other hand, this is also good for compilation. So if you don't have any other Java code, for example, you don't use Dagger, which would give you Java as well. So if you don't have any other Java code in your project, you don't have to run Java-C anymore. So it's really nice that Moshi generates Kotlin code for us. And it also generates quite idiomatic Kotlin code. So you can see the build string function being called here. That's a function from the Kotlin standard library for building strings. So Moshi is very, very aware of Kotlin and using it correctly. So this generated adapter implements the JSON adapter interface. And other than the toString implementation, we're going to look at the from JSON method, which we've just written by hand as well. First off, the signature is the same. We're going from a JSON reader into a burger. We're doing this same pattern of declaring each field as a local variable, which is nullable. Then we're going to loop through all the values. And within the loop, something new happens. So previously, we were taking the next key from the reader, just comparing it as a string to all of the possible keys within our object. So we were checking if that string is equal to the name string. We were checking if that string is equal to the price string. And if you did this for large models, you would be doing this linear scan of the list of strings, which is quite expensive, just to compare each string and try to find which one you've actually encountered in the input and to parse the corresponding field. So Moshi uses this options thing, which apparently contains name and price in some way. Now, this looks like a list, but this data structure, this options thing, is actually a trie or a tree, depending on how you want to pronounce it. So it's a TRIE structure, which is this great data structure for doing prefix matching and storing a lot of strings and efficiently finding certain strings in there. So this makes it a lot more efficient than what we've been doing before. After that, it just returns the index of whatever field we encountered. So if it was the first one, then it returns 0, and we're going to parse a name. And otherwise, we have price, and also the last case where we just didn't find a match within that data structure. Now, previously, when we wanted to parse the name, we just called reader.nextString, but that's not how Moshi's generated adapters work. Instead, Moshi will delegate parsing each of the fields in the model object to another adapter. In this case, this is not very exciting. We just parse a string and an int. So we might as well have called just reader next string or reader next int. But if we had other types of nested objects, this would be a lot more exciting. But you can see that all of these adapters will actually be listed in the body of the generated adapter as various properties. And all of these just access Moshi and, well, just use its basic APIs of grabbing an adapter from it for the given type. Oh, and also there's actually an article at the end of this talk in the resources which talks in more detail about this pattern of delegated adapters, which is worth reading. At the end of the method, we just wrap things up. So we consume the end of the JSON object, and we try to create a burger instance. And again, I was just producing null pointer exceptions if one of these values were missing. But again, Moshi generates really nice Kotlin code for you. So for example, if one of the values is missing, it's going to use this always operator, and it's going to throw various exceptions, which, as you can see, will include the exact names of the properties that were missing. Let's see how Moshi deals with built-in types. We've seen at the start of the talk that Gson was very happy. It ships with support for some built-in types, and it's very happy to serialize everything else with brute force. Let's see what happens with Moshi when we try to serialize a date. And since I haven't written down the from JSON or to JSON call yet, you will probably figure that I will not be able to grab this adapter from Moshi. It's going to throw an exception. It will tell us that this platform class, which it recognizes it to be, needs an explicit JSON adapter to be registered. So out of the box with Moshi, you cannot parse or serialize dates. Thankfully, you don't have to write this logic yourself. Moshi has an artifact that you can include called Moshi adapters, which includes a bunch of default adapters that you might need for various use cases. And you can use the Moshi builder to add instances of these adapters. For example, for date parsing, there is the very aptly named RFC3339 date JSON adapter class, which follows that exact specification, which is actually just ISO 8601, which is, well, this format that hopefully everyone is familiar with. So for these kinds of parsing needs, you can use these adapters that Square ships for Moshi. Let's talk about field naming next. So you can do the same thing as what you've done with Gson. You can name each individual field using annotations in Moshi, and those names will be used for parsing and for serialization. So if I were to take one of these burgers now, run it through Moshi and serialize it, I would see the annotated names show up in the output. However, this is not something that the creators of Moshi prefer you to do. What they want you to do is simply this. Just use the field names as is for the names of your Kotlin properties. This obviously breaks the coding conventions we have in Kotlin. However, it makes your code very searchable. Like at this point, you can grab for any of these field names in your code base, and you'll find all of its usages as well as the declaration. And also, you're probably going to be mapping your network models to something else anyway. Like hopefully this doesn't make it to your business logic or your UI. So in that case, the usages of these fields, these properties, will really be constrained to your networking code and like the mapping code that's around it. So it's not like you're going to have business logic with these ugly property names in it. And everywhere else, having to use this will remind you that these are your network models, so you should be using them consciously. Oh, and of course, given that, the reason why those annotations are still present is because you might have things like spaces in your JSON keys if you have really, really hostile backend people. let's see how Moshi deals with missing data. So let's do the burger example again and try to parse a burger that has a name and a price, but the JSON only contains the name of the burger. Moshi is not going to parse a 0 value for our price, as you might expect at this point. It's going to throw an exception instead, which tells us exactly that a required value called price is missing at $sign marking the root of the object that we were trying to parse. So this is great. We're going to fail early, and we're not going to have any implicit things happening in our code base. What about reference types? So what if I had a string that's missing from the JSON input? Well, same thing, unsurprising, required value description is missing. What if I make the description property nullable? Well, Moshi is going to understand that, and now it will allow the missing value, simply leaving null in there, because the compiler is going to force you to handle that null case anyway whenever you access the description. And finally, something we tried previously with Gson, what if we just use a default value, and if we know nothing about our burger, we're just going to say that it's one of our best burgers, like surely that's true. Moshi is going to be able to pick that up for you. So if the value is missing from the JSON, but there is a default value for the property, then Moshi is going to create an instance that has that default value in it. And the reason, among other things, why this is working so well and why Moshi respects all of these Kotlin features so well is because Moshi will always invoke the constructors of your models. So whether it's using reflection or code gen, it will always call the real constructors of your models. So if you were doing something horrible in there, like running code in the initializer blocks of your DTOs, that would actually always get executed if Moshi is creating the instances. It's doing none of the nonsense that Gson is pulling with just new instancing everything. Let's talk about customization options. So we've seen that with Gson, we have a bunch of global customization that we can do on the builder. But with Moshi, all we can do with the builder is add more adapters to use. So Moshi does not have this approach of globally customizing things. It doesn't like that. What we can do instead is local customization of these JSON adapters that we use. So let's take an example where we make the price of our burgers nullable. And I'm going to create a burger that has a null price. Maybe this means that we're no longer offering this. It's not on sale at the moment. So if I try to serialize a burger like this, then Moshi is going to omit the null value from the JSON because it looks redundant. On the other side, because this is an optional value, we can just leave it as null when we're parsing it. So it doesn't really make sense to put in price null into the JSON. But if your needs are different, you can customize the JSON adapter, as I mentioned. So you could call methods. There are a bunch of methods that you can call on a JSON adapter that will give you a new JSON adapter that wraps the original one, but they modify the behavior. So for example, we can do this serialize nulls wrapper, which will now output null as the price. Next, let's take a look at what happens if we just try serializing null itself with a burger adapter. So the entire burger is null in this case. I'm actually wondering what people expect. So who thinks that this is going to succeed and Moshi is going to be able to serialize this? Nobody. OK, so who thinks that this is going to throw an exception? OK, a bunch of people. So Moshi actually supports this by default. In its generated adapters, if you run a null value through it, then so if the entire object was null, then it's just going to output null in the value in the JSON. But if you wrote your own custom adapter, for example, where you didn't handle the null case, you can use a null safe option on the JSON adapter that wraps the original one. So it just maps null values to nulls. And if it wasn't a null value, then it will invoke your original adapter code. And if you want to prevent this from working, you can always wrap an adapter with non-null, which will throw exceptions whenever you try to pass a null value through it. What else can we do with Moshi? We can parse something like this. So here I finally have the correct JSON that actually includes all of the fields of the burger, which of course works correctly. But what if we have some extra fields in there, such as a rating, which is not present in the data class that I'm trying to parse this to? Moshi is fine by that by default. It's a common case that we have large API responses and we don't actually want to parse all the fields because we're not going to work with them. So Moshi doesn't mind this. But again, you can customize this. If you want Moshi to fail on unknown fields, for example, you're debugging or you're just very strict about your API contracts and you want to make sure that the JSON is just what you're parsing and nothing extra, then you can add this fail on unknown wrapper on adapters, and this will now produce an exception, which again is quite nicely worded. It says it cannot skip the unexpected rating field. Finally, again, the ultimate example of when things go wrong, which even Gson failed on, so Moshi is surely going to fail on as well, is going to be this burger and then a list of burgers in our restaurant. Again, we have this JSON where we have a burger that's priced at a crocodile, and we're going to try parsing this now using a Moshi burger adapter. It's going to produce this exception, which is so much better than JSONs that it's hard to describe. So first of all, it says expected an int, but was crocodile, which is just great on its own. But the important part here is that it tells us that we were trying to parse an int. With JSON, we were just getting a number format exception, which is a lot broader. But it also tells us that this happened at that specific path. So let's take a look at what that path is. So we start from a $, which marks the root of the JSON. Then we go to the menu field within there, which is an array. We go to the index 2, which is the third element. And finally, it was the price of that element that failed. So Moshi doesn't just tell us that something went wrong, or like I couldn't parse a string into a number. It tells us what the string's content was, what the type was that we were trying to parse it into, and it will lead you to where that happens specifically within your JSON, which makes debugging just so much easier. Again, to compare, this is what Gson was giving us previously, number format exception for input string crocodile. And of course, again, for the more interesting example where, for example, this was an empty string, with Gson, this is really hard to track down. With Moshi, you just keep following the path, and you'll see where it happened. Given that we're doing Android development, I have to mention retrofit, at least briefly. So if you want to use Moshi with retrofit, it's really easy to integrate, of course. So there's a Moshi converter artifact that you can add to your applications. And then all you do is, when you're building your retrofit instance, you add a Moshi converter factory in there. And if you need a custom Moshi instance because you're adding custom adapters or the reflection-based Kotlin adapter or any of those things, you can just pass in that specific Moshi instance to this factory, and that's going to be used for serialization. Now, there is a lot more to Moshi than what I covered in this talk. There are other built-in adapters that you can use. There's this great API of being able to parse data into intermediate objects and then continue parsing from there. You can annotate types. So for example, if in some part of your code base you're parsing ints as number values, and in some other part you're parsing it as enums or doing something completely different with the same type, you can use different adapters, even though in both cases you're parsing into an int. There's also, well, a lot more things. KSP support is something I want to highlight. So I've shown you how you can use Kotlin's annotation processor, capt, for Moshi, but there's also KSP support upcoming, which is not in the main Moshi artifact yet, but it's available in an extension called Moshi X, and it's going to be merged quite soon. So if you're migrating away from capt and you don't want to use it anymore, KSP is coming soon to Moshi. And with that, here are some resources that you can check out. I'm going to have a better link to these in a couple of slides, so you don't have to like type down or like note down all of these individually. So a few OK libraries is this hour-long talk about this group of libraries and how well they work together. JSON Explained is, first of all, a great explanation of JSON. Even if you're using it every day, you're probably going to learn something new about how JSON works, the spec, or maybe how numbers work in JSON. So that's really worth watching. It also includes a comparison of the 4 libraries that I mentioned, the 4 serialization libraries, so Kotlin X, Moshi, Gson, and Gson. It compares all of those in terms of APIs, error messages, and so on. And then here are some written things. So there's the announcement post of Moshi. Moshi is actually created by the same team that worked on Gson. It's just like a really evolved version of it, which is why it became a separate library. And, well, it was moved from Google's domain to Square's. There's a couple articles here that talk about Moshi's code gen in detail, as well as the delegated adapter pattern that I showed you earlier. And finally, there's just an article here about advanced things that you can use while parsing things with Moshi. So that's a wrap. You can follow me on Twitter for Android and Kotlin stuff. You can go to my website, which has all of these resources and all of the slides and everything else you could be looking for. And to summarize, Moshi can be used with reflection, code gen, or both if you really want to. It's Kotlin friendly. It's really fast and efficient in combination with OKIO and the other libraries. It has great failure modes. It's very strict about what it allows you to do. And it just has really neat APIs in general, which is, of course, subjective, but that's one of the main selling points of Moshi, that it tries to be as straightforward as possible. That's it. Thank you. I assume we have time for questions. OK, we have 5 minutes, and we have a question already there. We'll get you a mic.
So if you had a fourth element to Burger that was not populated, you want to post it to the server, if it was null, can you make it skip from the generated JSON as well? Something you can't do in Gson at the moment.
That's an excellent question. You can decide whether or not you want to serialize null values.
So the outputted JSON would not have the extra key value pair in it?
Yes, that's correct. By default, I think this is something you can do in Gson as well. I think this should be a global setting on Gson, but you can do it in Moshi. By default, it doesn't write null values, and you can customize the adapter to serialize nulls if you want to include it for some reason. Any other questions? Here's one on the front.
This is a general question. So we recently migrated from Gson to Kotlin X serialization for our app. But I was just wondering, like, I haven't really heard of Moshi before, but what would be, like, do you have an idea between Kotlin X serialization versus Moshi? Is there pros or cons for using one or the other?
OK, so for Kotlin X versus Moshi, so if you need multi-platform support, then there's no argument, because only Kotlin X will do that for you. If you don't need it, you might still expect to need it in the future. So Kotlin X might be like a hedge for that. Otherwise, I think it's fairly subjective. Kotlin X has mostly caught up to Moshi now. I know that it used to not have a stable API for streaming, parsing, and things like that. I assume that Moshi is still more efficient on the JVM with the way that it interacts with OKIO. But you would have to benchmark them, of course. And well, it's also just a subjective choice. So looking at the API of the two libraries, what writing custom adapters, what customization is like, it can be up to personal preference or whatever your team prefers. I like Moshi's APIs a lot more than Kotlin X's. So I tend to use this, but I also don't work in multi-platform, for example. All right, I think that's it for questions for now. You'll obviously find me here later. You can also find me after the talk on Twitter or the Kotlin Lang Slack, which is a very easy way to reach out to me. And yeah, again, just thanks for coming to this talk.